Hello everybody. So what we're going to be looking at today is derivatives of the trig functions. And really, if you combine this with the power rule, that's going to be all of the things you need to know the derivatives of for this semester. So that's nice. Let's go ahead and get started. So I think what I'm going to do is I'm going to write them all down here for you, and then we're going to look at them individually. So let's just write them down. So we're looking at trig functions. So the derivative of the sine function is the cosine function. All right, and something I'm going to do right here is, and I'm going to do this for everyone after this, is it's actually a better idea to, instead of memorizing that the derivative of sine x is cosine x, is to remember it this way. Now, this is technically going to use something that we're going to talk about in the next video and not this video. And that is what to do with like a constant right there. So that's like sine ax is like sine 3x, sine 4x, sine negative 2x, whatever it is. Okay, so that's just a constant. How is that going to affect the derivative? Well, we're going to learn in the next lecture that it just does this. That your answer for the derivative of sine ax is going to be cosine ax, but then the a means you're going to have an extra a right there in the answer. Okay, and I think that it's going to be better for you just to remember it with the a there, rather than have to apply a complicated rule, or you want to just remember it that way, so you have to do less work later on. That's what it comes down to. Okay, so I will write them all that way. So the derivative of sine ax is a cosine ax. The derivative of cosine ax is negative a sine ax. So again, the a is extra, right? So if you take away the a, it's this. Derivative of cosine x is negative sine x. And then we're just adding in the a to see what it does, and it just adds it right there. The derivative of the tangent, I should have put the ax again. Tangent ax is going to be a secant squared ax. Then we have three more. The derivative of the secant ax is a secant ax tangent ax. The derivative of the cosecant ax is a cosecant ax cotangent ax. Actually, it's minus that. And I should have put this next to the tangent. Maybe I will actually do that. The derivative of the cotangent ax is negative a cosecant squared ax. And there you go. There's 6 trig functions, so there's 6 trig derivatives that you need to know. Sure, why not? So there they are, and you'll notice that they come in pairs, right? Like the sine and the cosine basically have the same formula there, and the tangent and the cotangent basically have the same formula there, right? So the derivative of tangent is secant squared, and the derivative of cotangent is cosecant squared, but negative. And then we have the last ones, secant and cosecant. Same thing, it's almost the same formula. So if you can remember 3 of them, you can remember 6 of them. Okay, so they come in pairs like that. Notice that the derivative of every function that has a co in the name, so that's cosine, cotangent, and cosecant they all have a minus sign, right? All cofunctions, all cofunction derivatives have a minus. And there you go. Okay, so honestly, like what is in this box right now is everything you need in order to do this section. Okay, however, you know, that's not enough. We want to come up with like some of the formulas at least. So let us come up with the formula for sine x. So let's derive the formula for the derivative of sine x. Now, in order to do this, you need to know these two limits. You must know that the limit as h goes to 0 of sine, I'm going to write this like with a theta, just to make it clear here. This is not the variable we're going to be using. That's why I'm using a theta. So the limit as theta goes to 0 of sine theta over theta, you might remember, is 1. And you also might remember that the limit as theta goes to 0 of cosine theta minus 1 over theta is 0. Right? So you need to know those before you start deriving this. Okay? Now that we've done it, let's do this. So I know that the derivative of sine x by definition is the limit as h goes to 0 of sine a plus h, no, we're going to do this with an x, sine x plus h minus sine x over h. Okay, that's by the definition of the derivative. Okay, so far so good. But we can't really do much with that because we don't know how to deal with the sine x plus h. So what you're going to have to do is we're going to have to take this sine x plus h and we're going to have to look up a trig identity. So use a trig identity, which I have written down, but I don't see it, so I'm just going to go find it. Probably would be faster to do this than to go to our webpage here for our class. So what I'm looking for is one of these. Where are we? No, not one of those. Yep, it would have been faster to go to our own webpage. I thought that I would be able to find it with a Google search in like slightly faster. But it turned out to be slightly slower. Okay, we'll do this one. Study sheet. So here's what we want. We want the sum and difference identities, right? So what we've got is a sine of x plus h. So if you look at this formula, the first one in the sum and difference, if we have sine of theta plus phi, it's sine theta cosine phi, and then it's a plus. So if it's a sine with a plus, we get a plus. So what's that say? What I'm saying is this. So we apply that identity, this one, sine a sine a plus b is sine a cosine b plus, and then it was going to be cosine A sine B. Is that right? Let's double check it. Yeah. So sine, cosine, cosine, sine with a plus when there's a plus. Okay, so that should be good. So that's the identity that you need to apply here, but your A and your B are the x and the h. So this is a limit as h goes to 0 of what? Sine x cosine h plus cosine x sine h and then minus sine x. So this is what the trig identity did for us, right? We got this, and then this is over h, right? Now then what you want to do is you want to kind of group these things here. So what we want to do is, let's see, we want to group it to where we can factor something out. So let's rewrite it this way. If I rewrite it where I've got this term, which has a sine x, next to this term, which has a sine x, and then I split it into two fractions, I can write it as sine x cosine h minus sine x over h, and then as a separate fraction I'm going to write this one by itself. So we'll have it as plus cosine x sine h over h. Yes. Okay. So that's what I want. Now then what I can do is I can just rewrite this again, and here's what I'm going to do. I'm going to do two things. Number one, I see that this has a sine x and a sine x. That's what I wanted. So I'm going to factor that out. And I'm actually going to take it out of the whole fraction. So I'm just going to have a sine x, and then what I'm going to be left with is cosine h minus 1 over h. So that's what that first term is going to be, right? Like if you take away this sine x, you're going to have cosine h. And if you take away this sine x, you're going to have 1. So that's what I'll get. The other thing I'm going to do is I'm going to, on the second one, there's nothing to take off really except the cosine x. So I'm going to write the cosine x off to the side. All right. Now, then if I use the properties of limits, I can rewrite this again. I'm going to apply multiple properties of limits in the interest of time. So this first part right here, I can take a sine x out and then have a limit as h goes to 0 of just cosine h minus 1 over h. And the reason I can do that is because I'm going to write this one as its own separate limit. Limit as, limit as h goes to 0 of, and I'm going to take the cosine out and write it as sine h over h. Now I know that, I did a couple of things there in that step, but you should be able to convince yourself that that's okay. Then what I've got to do is I've got this limit right here and this limit right here. But by magic, those limits are exactly the limits that I said we were going to need to know before we started, right? So I've got the one with the sine is 1, and the one with the cosine there is 0. So this one is 0, and this one is 1. So you write out what you get, and what you will get is that we have from this sine times 0, which is 0, and from this one we have cosine x times 1, which is cosine x. So that's your limit. So what did we do? We just discovered that the derivative of sine x is the cosine x. All right, and you can do the same thing for the cosine. The one for the cosine is almost the same exact proof. Okay, now all of the others though are more trouble to do. I'm trying to think of what the easiest way to do them is. Yeah, actually, we do not have enough math right now to to prove any of the others other than sine and cosine. So we could prove the cosine, but we couldn't do the tangent or cotangent or secant right now. Oh wait, you know what? I lied. We can. All right, let's do one more. let's do one more that we can do. So let's come up with the one for tangent. Derive the formula for the derivative of the tangent. All right, so here's how this would go. We don't need the definition anymore. So the derivative of tangent x is the derivative of the sine over the cosine, right? Because the tangent is sine over the cosine. And we know how to do this derivative because we know the quotient rule now. So remember, the quotient rule says that the derivative of f over g is f prime g minus f g prime over g squared. If you apply that here with, this could be your f and this could be your g. Move out of the way notification so I can pick a color. Okay, quotient rule. So the top is f and the bottom is g. So what we get when you write out the quotient rule here is you get f prime g minus f g prime all over g squared. So that's your quotient rule, right? You just put everything where it goes. So like your g is on the bottom, so that's a g, that's a g, that's a g, and your f was on top, that's an f, that's an f. So just copying the formula here, right? F, f, g, g, g. Okay? So that's the quotient rule. Well, then you actually have to do this work. Now, in order to do this, you have to already know what the derivatives are of sine and cosine. So I know we only did sine, but we're going to have to deal with it here. So what's the derivative of sine? We just came up with it. It's cosine. And then there's another cosine. And then minus sine. And then you have the derivative of cosine x, which you have to look up. The derivative of cosine, oh, oops, I didn't put the a back. But the derivative of cosine x is negative sine x. So negative sine x all over the cosine squared, which is just the cosine squared. Then on the top there, you have cosine times a cosine. That's a cosine squared. Then you've got a sine times a sine. That's a sine squared. And overall, there's a minus and then another minus. So that's going to be a plus sine squared x over cosine squared x. Then at some point in your life, you must have learned that cosine squared x plus sine squared x is 1, right? And guess what we have right there on the top? Cosine squared x plus sine squared x. So you're going to apply that identity and you just get 1 over cosine squared x. But 1 over cosine squared, 1 over a cosine is not a sine. That's a lie. 1 over a cosine is a secant. So 1 over cosine squared is secant squared. And we're done. So what we did was we found that the derivative of the tangent was in fact the secant squared. Okay? And you can come up with the others in a similar way. Like you could do the one for secant, right? Oops. You could write secant as 1 over the cosine and then do the quotient rule. But it's a little bit of algebra to make it come up the way you want to look at the answer. Like you can get the answer, but it's not the way you want to look at the answer. It's like written in the wrong form. But anyway, you can derive all these. You don't need to derive all these. You need to know all these. Okay, so like the work that I did here for the sine, that's great. you don't need to know it. The work I did here for the tangent, that's great. You don't need to know it. Right? So what do you need? Okay, you need to be able to use these formulas to solve problems. Right? Use the formulas to solve problems. Now, what kind of problems? All of the normal problems that you guys have been already working with for finding derivatives, right? So the first question in the homework on my homework was, they say, what is the derivative of f of x equals negative tan x minus 5 cotangent x. Okay, I didn't write that big enough. I'm writing it here. F of x is negative tan x minus 5 cotangent x. Also notice that whether or not you put parentheses around the x there is just kind of down to whether you felt like it on these, unless there's multiple variables inside there. All right, so there we go. What's the derivative of this? So all you're doing is you're just looking up the formulas and making sure you know how to apply them, right? F prime, you don't have to write this line, I just am. We're just taking the derivative of this. All right, so what's the derivative of tangent? Well, negative tangent. So just carry down the negative, and then what's the derivative of tangent? Just look it up. The derivative of tangent x is secant squared x, right? Our a is 1, so the derivative of tangent 1x is 1 secant squared 1x. Or easier, just the derivative of tangent x is secant squared x. Easy. Now, what about the cotangent? Well, you got minus 5. So we know from the rules for derivatives that you just carry down the minus 5. And then what's the derivative of cotangent x? Well, look up here. The derivative of cotangent x is negative cosecant squared. So we just say negative cosecant squared x. All right, then just work out the signs. So we got negative secant squared x, and then a minus minus, a minus minus is going to be a plus 5 cosecant squared x. And that's it. That's all they expect you to put in for your answer. Just like that. Right? So you just have to look up the answer for the derivative of tangent and the derivative of cotangent. Now you need to be able to do this at specific points, and you might even need to have to do what's it called, tangent line problems, but this one isn't. They say, what is the derivative of f of x equals 4 cosine x minus sine x at x equals negative pi. So they're giving us a point. That's fine. F of x is, I'm writing the original again, 4 cosine x minus sine x. So f prime of x is the derivative. So we're going to need the derivative of the cosine. What's the derivative of the cosine? It's negative sine. So the answer is going to be negative 4 sine x. Then we're going to need the derivative of the sine. The derivative of sine x is cosine x, and we have a minus sign already in front. I don't know why that's pink. So we have a minus sign in front, and then the derivative of sine x is cosine x, like that. So there's your derivative. They say they want it at negative pi though, so you're going to have to plug that in. F prime of pi, negative pi, is going to be negative 4 sine negative pi minus cosine negative pi. Now you want to make sure that if you're plugging in numbers into your trig functions, you're either using a calculator that works symbolically, or you're using like Wolfram Alpha or something, or you just need to know the end. So sine negative pi is actually 0. So this first one is 0. And then cosine negative pi is negative 1. And then it's minus minus negative 1, so that's actually plus 1. So the answer there is just 1. So you find the derivative, you plug in the number, and you are done. All right. Now, like I said, you're probably going to have to do tangent lines. So find the equation of the tangent line. 2 f of x equals negative 3 cosine x at x equals negative pi over 3. All right, so this is an equation of the tangent line problem. So remember, equation of the tangent line, you need a point and you need a slope. Okay, so for the point, find the point. Well, we already have x equals negative pi over 3. So that's half of my point. I need the y value. In order to get the y value, you're going to plug it into f of x. So the y value is going to be f of negative pi over 3. So we'll plug that in. We get negative 3 cosine negative pi over 3. Work that out on a calculator or Wolfram Alpha, or just know the answer. So on the unit circle, come on. Negative pi over 3 is negative 60 degrees. And the coordinates there are going to be positive 1/2, negative square root 3 over 2. So cosine there is the x value is going to be 1/2. So negative 3 times 1/2 is negative 3/2. So I've got the y is negative 3/2. So that's my point, right? I've got the point now. Xy is negative pi over 3, negative 3 over 2. Now that's not the answer to the question, that's just the point. To write the equation of a line, you also need the slope. Right? Now the slope is the derivative at the point. So what is f? F of x is negative 3 cosine x. So you simply find the derivative. The derivative of cosine is negative sine. So negative 3 times negative sine x, which is 3 sine x, positive. We need the slope. I'll say m. M is what we usually use for slope, is f prime of the point. What's the point though? What's the x value for the point? So we need this at negative pi over 3. That's the point that has to go in. So we need 3 sine negative pi over 3. Well, the sine of negative pi over 3 is the y value at that point. So it's going to be 3 times negative square root 3 over 2. So it's negative 3 root 3 over 2. Now I've got my slope. I keep doing that. Always. So there's my slope, right? m, which is the derivative evaluated at the point, is just this number. Well, okay. So now I've got the slope and I've got the point. So now we can write the line because we got, wrong color. So now we've got a point which was negative pi over 3, what? Negative 3 halves. And we got a slope, which we usually call m. M equals negative 3 root 3 over 2. So we write our line. So the line is going to be y minus y1 equals m x minus x1. And we've talked about this before, but remember, the x value is actually x1. The y value from the point is actually y1, not y. And the m is the m. So you fill these all in. Y minus 3 over 2 equals negative 3 root 3 over 2 x minus x1, which is negative pi over 3. So you get y plus 3 over 2 is negative 3 root 3 over 2, x minus, or actually plus pi over 3. And then all you have to do is move that 3 halves over and have y equals negative 3 root 3 over 2 parentheses x plus pi over 3 minus 3 halves. And you can multiply that out or not. I would just type this in to the computer. Actually, kind of interesting, something that's kind of interesting is that on the computer they actually put it in like this. They didn't even move the 3 halves over to the side, which that's unusual. Usually people will write it like this. Okay, so that's a whole tangent line problem. They are all kind of the same. All right, now they're going to combine this with the product rule and the quotient rule as well. So they'll say something like, let h be f over g. They write of h, but I'm lazy. Where f of x is negative cosine x, g of x is 4x squared plus 2x minus 3, and they say find h prime. All right, and so if they do this, which I mean they do because this is from the homework, write out what h is. So h, they say, is f over g, but actually write out what it is. Don't try to do it without this, just because you want to be able to look at it while you're doing the problem. So this is what h is. Okay, now we need to take the derivative. Now what's the appropriate technique for the derivative? You should know this is going to be the quotient rule. And remember how it goes. So when you do f over g prime, it's f prime g minus f g prime over g squared. We did that once already today. And just keep track of what is what, right? Like, like the f's on top, and you have an f and an f. I feel like you can't read this anymore. The g's on bottom, and you have a g and a g and a g, right? So we've got our g, got our f, and then we want to write out what the quotient rule says. So you do this in, well, I do this in 2 steps. So I just start with my formula. F prime f prime. Then g. G is the entire denominator. We're going to have to move this over. As far as it goes. All right. So that's f prime g. Then you have minus f and then g prime. G is the denominator. Prime. All over g squared. So g squared. Now, if you look at this, we've only got two derivatives to do. We've got this derivative, the derivative of cosine, and this derivative, which is the derivative of a little polynomial that you're going to use the power rule on. So we're just going to take those two derivatives now. When we're done, we're done. So what's the derivative of negative cosine? The derivative of cosine is negative sine. So you have negative sine x, which of course is plus x. The polynomial here, you're not taking the derivative of, so you're just rewriting it. This cosine, you're not taking the derivative of, so you're just rewriting it. Although you can do the minus minus there and turn that into a plus. But we're not doing any derivative there. And then on the other orange one that I highlighted, we are taking a derivative, so power rule. So we need the derivative of 4x squared, that's 8x, plus the derivative of 2x, that's 2, plus the derivative of negative 3, which is 0, right? The derivative of a constant is 0. So I've done my derivatives at this point, right? So I've got this written here. I'm technically done with the derivative. All you want to do is, you know, if you can, then like do a little bit of algebra to try to clean this up. So like negative sign here at the beginning, right here, that's a sign, that's just a plus sign. So we can just write sine x, 4x squared plus 2x minus 3 plus cosine x, 8x plus 2. Then you can look at this and you can decide whether or not it's worth to multiply out the numerator. And I think it's not, because if you multiply out the numerator, it's just going to be more terms. And we're not going to be able to cancel anything or anything. So I would just stop here, call it a day. Does that make sense? So really the only new thing there was, what is the derivative of cosine? Right? So there's really nothing to it in that sense. So a quick look at the answer on this one. They wrote it exactly like my previous line. So identically to what I did. Blah, 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 blah. Yeah. So let's do the next one. Just a basic derivative here. All right, and they just want the derivative. Find f prime. That's it. So we want the derivative. This is very straightforward. You're just starting to memorize these derivatives at some point. You need the derivative of the cotangent, and you need the derivative of the secant. So you go look those up. You have -5, and then you find that the derivative of the cotangent is negative cosecant squared x. All right. And then you look up the derivative of the secant, and you find that the derivative of the secant is secant x tangent x dx. So what do? I said dx, but we're not actually writing them that way, so ignore that. So there's really nothing to do here. It's going to write your answer, and that's that. So super super easy here. Hold on. What did they do? Oh, that's dumb. Why would they possibly do that? I don't know. Okay. They did a really weird thing with their derivative, and that was making me wonder why. They used a trig identity. They got to the end here, and then they just used the trig identity on this for no reason at all to write it as a cotangent. Made literally 0 sense. Let's do another. No, actually, let's do a product rule one, and then we're gonna stop. Mostly because I'm out of time and need to do my office hours. So let's say this. Let's say we have f of x equals, I'm going to say sine x, and then times, let's say, not cosecant because that's too easy. Let's say cotangent x. Let's just, actually, no, let's do tangent. Okay. Let's find f prime. All right, so what you'd have to do here is you would have to do the product rule this time. So the product rule says that when you do the derivative of f times g, that it's f prime g plus f g prime. Now, for purposes of the product rule, the first one's my f and the second one's my g, not the original function, which was called f. So when I write f prime, I mean sine x prime g, just write it like that, and then plus f, that's sine x with no prime, times g prime, which is tan x prime. So you write out your product rule, that's what the product rule says, and then again, all you're doing here is remembering what these derivatives are at this point. So what's the derivative of sine x? Cosine x. And then tangent x plus sine x. And then what's the derivative of tangent x? It is secant squared x. All right. Now there's a easy amount of simplification I would do here. So we have a cosine x times tangent x, but if you remember that a tangent is actually sine over cosine, then what happens is if you multiply a cosine times a tangent, the cosines cancel there and they're just going to leave you with a sine. So actually this is just sine x. So sine x plus sine x secant squared x. Strange, but true. Now what happens if you write the previous line? That's perfectly fine. You'll get it right if you write the previous line. All right. So that is it for this lecture. So you still have product rule, you still have quotient rule, you still have equations of tangent lines. The only new thing is, like, what are the derivatives of the 6 trig functions, which I wrote here. But in this first assignment, everything is, all the A's are 1 in homework 16. Okay, all right.